I think that doing science is a deeply personal experience that is often tied tightly to deeply seated intrinsic interests, and it may be very difficult for any individual to figure out why it is that they're interested in a particular topic or idea. And people come at their interests from so many different directions. I think that some scientists, not all, but especially some naturalists, start out simply finding shells attractive to look at and collect. Some simply like the way rocks look and like to climb on them. Some people simply love being outdoors and love being in an incredible landscape. Many people begin their careers in science, at least in certain kinds of field sciences, taking a field trip as part of a class and recognizing that their favorite part of doing the work is being outdoors. And I think these are all aesthetic experiences. By themselves, they don't make one a scientist. You might consider them to be a perk in some ways. But I think that they are deeply connected to our commitment to sticking with those topics and our interest in understanding them. But I'm sure the same could be said about people who are doing certain kinds of chemistry and physics and mathematics, who feel that a certain kind of solution may be simplifying a phenomenon that appeared at the surface to be very complex, can be simplified in several formulas that help explain some basic underlying processes, or maybe even a computer model that can explain for the first time what appeared to be very complicated data. That also has, I think, an aesthetic beauty to it. It's difficult to describe what that means. It might be not unlike a deep insight from a poem or a piece of artwork. And I think almost all scientists enjoy their work at some level through those kinds of aesthetic experiences. I think of a naturalist as somebody who is studying science within the context of nature. In other words, it might almost be easier to give examples. So, for example, somebody who's out tracking organisms and looking at their distribution is a naturalist. Somebody who is tracking fossils through time in sequences of rocks is a naturalist. Somebody who's in a laboratory trying to understand the chemical properties of a substance is certainly studying nature, but we wouldn't traditionally call that person a naturalist. Certainly there's a fuzzy boundary, though, and I could imagine if a chemist were sitting next to me, they might disagree with that description. I think that it may be a truism to say that science touches everybody's lives, and so everyone needs to be science literate to some extent to make responsible decisions about their own health, the environment of their community, of the energy resources and economy of their country, and so on and so forth. So there are some basic understandings of science that everybody needs to have. I also think it's really important that people understand something about how science works, because it makes it much easier to appreciate scientific results, and sometimes the uncertainty of scientific results, and to interpret them and apply them to one's life. It's not uncommon for people that haven't been involved in science to feel terrific frustration when they read the paper and a previous finding is overturned, which is a really exciting thing for a scientist. But for the general public, that can be very frustrating. Well, now what do I do? Oh, those scientists, they never know what they're talking about. Or to find out that there's some possibility of a particular hypothesis not being correct, or maybe it's probably true, but we're not really sure, or those kinds of tentative statements that scientists habitually make. I think if you've participated in doing science, or at least you've had some experience in seeing how scientists go about doing what they do, it's easier to understand that this is the nature of science, that it's done, and also that it's done by humans who are doing the best they can to make sense of a complex world, and then to be able to make decisions one way or another about whether it could be applied to whether they're going to have a certain kind of surgery or take a certain kind of medicine or treat the land in their community in a certain way. So going all the way back to your original question, I think that universities need to help provide that kind of education, especially because understanding how science works often is not tackled very thoroughly in K-12 education. So it's often at the college level, and I gave myself as an example, it's not until the college level that students begin to actually come into contact with people who are doing science and opportunities to do science themselves. Scientists have traditionally not necessarily been tightly connected to the issues going on in local communities, but yet scientists at many universities often have expertise in issues that are really important. So locally, of course, we have an example like that right now with the likely drilling for gas of a formation known as the Marcellus Shale in central New York, in the southern tier of New York State. It's already been going on in Pennsylvania. Gas shale drilling has already happened in a number of other places in the country. There are those who see the profit in this, and it's exciting to think about either personal gain or community development. There are others that are extremely fearful, and both of those positions are perfectly legitimate. But there's a lot of complicated science that goes into making the decisions about when and where to drill, whether it should be allowed in certain places, what the regulations should be, what the relative risks are of different aspects of that process of gas drilling. So this is a perfect example in which scientists who have expertise in pieces of this process should be doing their best to provide good information to the public to the best of their understanding. And in this particular case, and maybe this is commonly true, it really takes a whole team of scientists of different backgrounds and different kinds of expertise to help the community to understand what's at risk, what are the potential gains, what are the pros and cons. And without that, people will still have to make decisions, but they may make decisions based on speculation or something they heard from someplace else that may not be well grounded in available scientific research.